All right. So till now we have created this thing, which is our kind of a UI. Okay, this is our actual code that we created earlier. Okay, and using this code we just saved our artifacts, right? And this is our UI. And here we created UI like this, right? Next, what we have to do, we have to use our artifacts, okay, such as our model file to build a model, okay, or to we will use our artifacts such as our model file, which can use this UI, okay, and with the help of this UI, we can make some sort of prediction, isn't it? So this is what we have to do. That means we can take the user input. Again, by taking the user input, we want to make some predictions. Okay, this is our ultimate goal that we have to do. So to do it, first what we do, I'll just create a new file over here. Okay, and that new file will be created just to check what, just to check this model file that we have created. Okay, this model file that we have created over here, this model file will just try to check it out, right? So for that, I'll create a new file, and thereafter we'll combine both the files together, right? So let's say here it's like I'll create a new file over here, and I'll give it a name. Let's say loan app test.py. Fine. Now this file requires what? This file needs to read your artifacts. Okay, what are our artifacts? First of all, I'll import numpy as np. Second, I'll import our joblib. Why? Because my model is using joblib to save the file. To again load the file, I required it joblib. Right. Next, I have to read what our artifacts. Okay. So how can we read our artifacts? We will do nothing. We'll just copy this thing that we already did earlier. Okay. Loaded model this one. Okay. This one. So this will load my model. Okay. Only thing, it's like the model file name should be same. It is load model.pickle. Okay. This will be loaded over here. Fine. Next, we also need one more thing. See, while coding, okay, if you see over here, before going for the training, here we trained the model, but before going for the training, we also scaled it, right? We scaled the data, okay, that is min max scaler we use, that is transformed in the range of 0 to 1, right? So that's why when we are kind of going for the prediction, we have to take the user input from the user, and then we have to again scale it and then go for prediction. Again, I'm repeating, for the training we scaled, then we trained. That's why for the prediction, first we scaled and then we predict. Right. So that's why for the scaling also we are saving our scaled version. Like you can say scalar.pkl. That means scaling information also we are saving as a pickle file. Same thing. Okay. Joblib.dump. What? Scalar. What is a scalar? A scalar is object representing scaling. And then we are kind of storing the scaling information as a pickle file over here. Okay, like this. Okay, and once we saved it, right, the same file we can access as an artifact, like we are accessing a pickle file over here. This is what our load model that we are loading. Then we will also import this scalar file, right? Once we saved it, we just put this scalar file into the same directory where our project exists. Okay, wherever our project, once you saved it from here, right? Once you saved it from here, thereafter these files will be saved here. From here you can download it if you want, like this. Okay, and once you download it from here, you can do what? You can just store those files in that particular folder in which your main project exists. Okay, like for example, our project exists here, Indie Drive, Loan, App, Streamlit. So here I just saved scalar.pkl and load model.pkl. All right. So now I just use over a scaling is equals to what? Joblib.load. Okay, what? Scalar.pkl. So what we did here, we just load our artifacts. Okay, two artifacts required. We just loaded our two artifacts. Okay. Now we will do what? We will create our function. Okay, which function? A function which can do the predictions. Okay. So let's say def prediction. Prediction. Okay, this function is being created to do the predictions, right? Now it will not do the prediction on its own. It requires some parameters to make the predictions, right? So what are the parameters it required? The parameters it will require will be like this, right? Like when user will enter the gender, so gender value will be required, right? Thereafter, when user will enter the next thing, which is your married, so married information will be required, right? Isn't it? So it's like married. Okay. So in this way, all the parameters that we are basically fetching from the user through UI will try to just use it over here, isn't it? Okay, education and thereafter self-employed. Okay, I'm just trying to copy and paste. Why? Because I'm just kind of putting like it, the spelling mistakes should not be done. Okay, just to avoid any spelling mistake, I'm just copying and pasting it over here. Applicant income, then co-applicant income required, right? So it's like ultimately applicant income and co-applicant income will be summed up, right? Thereafter, we have a loan amount and loan amount term, and then we will have a credit history and this thing. So loan amount and thereafter it's like loan amount term, okay, and thereafter credit history, okay, and last one is what property area. All right, all right. So these things are equal, right? Now what will happen with these guys? When this function needs to be used, what I will do, I have to call this function, right? So let me just copy this thing, okay, and paste it over here. Okay. So when I call these functions, or this particular function, I have to feed these value, right? So what value I have to feed? Like for example, for the gender, I'll feed what male or female, isn't it? So let's say for the gender, I'll define what female. Okay, for the married, I have to feed what no or yes. Just try to understand this logic very carefully. For dependents, I have to feed what the number of dependents, right? Like 1, 2, 3, or kind of a 3 plus. Thereafter, for education, I have to feed what graduate or not graduate, right? So graduate. Okay. So self-employed, I have to feed what that whether it is self-employed or not self-employed. So it's no or yes. For applicant income, some applicant income I have to feed. Let's say I'll feed over here 50,000. For co-applicant income, I have to feed the co-applicant income, isn't it? So let's say I'll feed over here 10,000. Okay. Loan amount, let's say I'll feed it over here as a, let's say 30,000. Loan amount term, let's say 360. Okay. And then credit history, I'll feed what 1.0. And property area, we have urban, semi-urban, and rural. So let's say I'm feeding urban. Okay. So these. So prediction functions should execute and give you the predicted value. But do you think it will give you the predicted value? It's like, because for the training, if you see, we had used what? We had used over the X-train, but before X-train we scale it, but before scaling we did one more thing, and which is called your what? Label encoding. Okay, we had transformed the data which was non-numerical like this, okay, into a numerical form like this. Okay, so for the training we use numerical information. So for the prediction, how can we use such non-numerical informations? No, right? So we need to do what? We need to again write a logic so that this can be converted into a numerical form. Okay, so here what I'll do, I'll start writing the things. Okay, like for example, I'll just write a functions. Okay, lambda functions for encoding. Okay. So question is what all things that we have to encode. We have to encode gender. So gender encode. Okay. Thereafter we have to encode married. So married encode. Okay. Thereafter I have to encode dependents. So dependents encode. Okay. Thereafter education. So education encode. Okay. Thereafter, self-employed, it is a numerical value, no need to, sorry, self-employed, we have to encode, yes, sorry, self-employed encode. All right. Thereafter, we have to encode what applicant income not required, self-co-applicant not required, loan amount not required, loan amount term not required, case history not property area. Okay. So property area encode, right? So these guys we needs to encode. So for encoding, we'll write a logic over lambda, lambda x. Okay, and here I have to give the condition what? That means you should return 0. Why 0? Because whenever the entered value will be female, it is 0, right? So I can just copy this thing. This is a pattern of encoding, right? So return 0 if, sorry, it should be numerical 0 if x is equals to what? Female, right? Else you can return what? Simple 1. That's it. Okay. Same way, I'll copy the same thing and I'll paste it over here. Okay. Return 0 if x is equals to what? No. All right. Then you can say education, it's like return 0 if x is equals to what? Graduate, right? For not graduate, it is 1. All right. Thereafter, self-employed. Okay, self-employed will be what? The same thing, like it is yes or no, I guess. So I can just copy this thing and paste it over here, isn't it? For self-employed, no, is fine. Thereafter, we have a property area in this thing. Two things are left. So for these two things, we have multiple. So 0 if it is what? Rural. Okay, for rural, it is what? 0. Else return 1 if x double equals to what? Semi-urban. All right. Okay. Else it will return what? 2. Okay, so 3 conditions are there, and then the same I'll copy it over here. Here I have to give what? 4 conditions. Return 0 if x is equals to 1. Okay, return 1 if x is equals to, so return 0 if x is equals to 0. Here we have what? 0, 1, 2, 3 plus, right? So 0, return 1 if x is equals to 1. Okay, return 2 if x double equals to what? 2. Okay, else just return 3. That's it. So here my functions are created. That means function within a function, right? These are lambda functions within a function, right? Now what happened? We can just use, thereafter we have a numerical value also existing, right? Like we have applicant income and so many things are there. So applicant income will be final applicant, you can say applicant income will be equals to what? Applicant income will be the sum of these two guys. Okay. And we call it, it will be the sum of applicant and co-applicant income. Simple. But is it done? No, this is not done. We need to do what? We also need to kind of apply the log transformation, right? Because if you see over here on a numerical value, we applied log transformation. Okay, here in this section, right? So we have to apply the log transformation on these three guys. Which one? The applicant income. So here I have to do what? Applicant income will be equals to, okay, applicant income will be equals to what? NP dot log of, applicant income. Okay, applicant income. All right. Thereafter, the other two guys, like for example over here, loan amount, right? Loan amount, and then after loan amount term, I guess. Loan amount term. Okay, these two guys also needs to be converted. So NP dot log of what? Your loan amount. Okay, and then here you can use what? NP dot log of what? Loan amount term. Right? So these guys will be converted into what? Into this thing, right? Now once you are taking these value, like you are calling this goes over here. We have a function, but we need to also do what? We need to also transform it. That means once it goes over like gender, right? So gender value came over here as a female. Okay, so once it came up over here as a female, we need to do what? We need to kind of call this function, right? So I have to call it like gender encode. Okay, and then I have to call the gender value over here, isn't it? Then only gender encode will return me what? 0 or 1. Okay, so now here we have a gender value, isn't it? This is updated, right? Same way I have to call what? Married encode, isn't it? And in the married encode, what I have to feed? no arrears. So no arrears is coming from here. So I'll take this thing, put it over here. And this will be the value of merit. Alright. Thereafter I have to call what? Dependents encode, same thing. Like all these guys I have to call one by one. So let me paste it over here. Education encode. Okay. Self-employed encode. Alright. Thereafter we have what? Property area encode. Nice. Okay. And here it will be what? Gender, married, then it will be dependents. Then it will be education. Okay. Then it will be self-employed. Then it will be applicant income. Not applicant income, sorry. It would be property area, right? So these guys will go to these lambda function and the outputs will be stored in the dependents. Okay. Here education. Okay. And thereafter self-employed. Okay. And thereafter property area. Alright. So now it's like when you call this function, these values will go as an argument. First, they will get encoded. The categorical value will get encoded. Numerical value will be whatever the operations required, like log transformation, addition, that will be done. And once everything is done, thereafter what happens? These things needs to go to model, the model that we loaded model, right? But before going to model, again, there'll be an input, like model requires what? A data in a series. Okay, it's kind of a sequential data, a kind of an array, right? So first we have to convert these guys into a proper array. So for array we'll define input data is equals to np.array. Okay, and then we will feed what these things. What I have to feed? I have to feed first gender. I'll say take the gender value, right? Thereafter married. Thereafter dependents. Okay. Thereafter education. Okay. Thereafter we have a self-employed. Okay. But after self-employed, we don't have a property area in the training data. When we trained it, what we use? If you see the training part, okay. After self-employed, we have used applicant, loan amount term, property area, and then this one, right? So property area is at the end. So first we have to do what? Applicant income that we created. Thereafter, we have to pass over here what? The next guy, what is it? Loan amount, right? Let me cross check once. Applicant income, loan amount term, and case history, right? Thereafter, I have to feed over here what? Loan amount term. Okay. Let me just put in the next line. Actually, later on, I'll put it in the same line, right? Loan amount term, right? And after loan amount term, I have to give case history, right? So case history we are not pre-processing anyway. Okay, we are using it as it is. So I can just use this thing as it is without making any change. So this is my case history. Okay, and at the end we have what? The last thing, which is your, I guess, after getting property area. All right. So this is a property area. So this is a sequence we are using for the training. Okay, the same sequence we put it over here. Someone now input matrix is done. So is it like we can pass input matrix for the prediction? No. Thereafter we have to do what? Scaling. So input data will be scaled now. For the scaling, we had already imported our module scaling, right? So it's like scaling dot transform. Okay, what I can do? I can just transform over here input underscore data. Okay, so now it will be transformed and the scaled value will be done. And once the scaling is done, right, what I can do, I can just now call over, now process is done. Okay, I can now call over here model, that model that's come, just be ready to predict the outcome. So loaded model dot predict. Okay, and I can put what? Input data. Okay, and this predicted value I can store somewhere, predicted underscore value. and then I can print this predicted value. Okay. Now let's see what happened. If I save this thing, so and I execute this file, it is expected that it should print me the predicted value. Okay, because already we are calling this prediction function. Alright. So let's go to the location where my file is saved, right? Run command prompt. Okay. And I'll just call the file name. What's my file name? Loan app test.py. So Python loan app, okay, test.py, right? Okay, let's say, okay, so it is giving the predicted value as 1, but it is giving as a square bracket, right? So later on using it for, on the EY, it can be a problematic. So what we can do, we can just use it over here, return at index 0, right? Now again save it, again let's check it out. Okay. So now guys, this thing is working perfect, right? Now as it is working, everything is fine. What I can do, I can just copy this whole thing, okay, and I paste it over here. Okay, this part, second part, I'll copy this whole prediction thing, okay, and I'll paste it over here. Okay, this predicted value and everything is fine, right? And here instead of print, I can just use what? Return predicted value. That sounds better. Okay, now once I return the predicted value within this thing, if the button is clicked, right, I'll say if the button is clicked, that means what? That means this guy needs to trigger the prediction function. Okay, that means when the button is clicked, I have to do what? I have to use result. Result is equals to what? I have to use this prediction function that we created. I'll copy this and paste it over here. Okay, that means the same function, I just put it over here, everything as it is. Now when the button is clicked, then I want to trigger that function, but this time I want to trigger it with what? With the value that user is entering. So this female will be replaced with what? Gender. No will be replaced with what? Married, isn't it? Dependents will be replaced with what? Sorry, this two will be replaced with dependents. Thereafter education, isn't it? Okay, thereafter we have self-employed. Okay, thereafter we have applicant income. Control C should be there, huh? Okay, thereafter we have what? Co-applicant income. Okay, thereafter loan amount. Okay, thereafter loan amount term. Thereafter we have credit history. Thereafter we have property area. Okay, so now we just did it, right? Now it's like, I'll just do what? I'll just create a logic over here. If the result is equals to what? 1. Okay, then I'll say what? That means st dot success. I'll compare st dot success. What is success? Okay, that we had already seen in the Streamlit tutorial, right? So st dot success will give me a result. Your loan application is approved, isn't it? And here else we will say that, sorry, made a mistake. It should be over here, colon, enter, st dot error. It will show the output in red color. Your loan application is rejected. Okay. So let's save this thing. Okay. And then re-execute this part once again and check if everything is working out good or not. So re-execute it is taking some time, right? The few information which are already given, I can make some changes if I want. Married, no, yes. What are dependents? Let's say 1, right? Education, applicant income, let's say 60,000. Co-applicant it is 0. Loan amount term, let's say 20,000. Loan amount term, let's say 240. Right. Gate history, let's say 1. Okay. Urban and then predict. So it is saying your loan application is rejected, right? Now let's make some changes. Let's add some co-applicant income. Let's say 20,000. Okay. And loan amount, let me okay, loan amount, let's say I'll make it 50,000. Okay. Loan amount term, let's say 360. Okay. Gate history, let's say 1.00. Okay. Let's say it is still saying rejected. Oh, it is showing what? Rejected. That means there must be some problem in the code. Okay. Let's see. So here we can compare gender, marriage, dependence. So here you can see education is used for 2 times, right? So that is a kind of error we did. So here it should be done what we took over self-employed, right? So it should be what self-employed, right? So just correct these things. Education here it should be what self-employed. Okay, and here also it should be what self-employed. Okay, now let's correct it. Now let's save this thing again. Let's check it out. Refresh it. Okay, and I'll make some changes. Let's say one. Okay, guess with this one. Okay, loan let's say 50,000. Okay, let's say over here 30,000. Okay, loan amount term let's say 360. Okay, loan amount or loan amount let's say 36,000. Loan amount term let's say 360. Okay, gate history let's say 1.0 urban. Okay, let's say. So now it is approved, right? So now it's working good. It will approve, it will kind of reject, both will happen. Let's say if I'll increase the number of dependents over here to 3 plus, okay, and I'll say self-employed, yes, okay, so it may be rejected. So it is still accepted, right? Let me use gate history as this one. Okay, so gate history, if I use 0 over here, let's say. Okay, so you can say now it is approving, rejecting both, right? So things are working good. Only one mistake we did over here. We just used education for 2 times. So apart from that, everything is working good. So what we had seen how can we create our kind of initial model, okay, like this. After creating this initial model, we need to save the artifacts. 2 artifacts we have saved. One is your model file, second one is your scaling file. These 2 things we take into the staging area over here where we are creating our model file. That means our deployment file. Deployment file, for creating a deployment file, we did what? In the first step, we create our UI using this. In the second step, we just try to use our artifacts. And when we tested our artifact and everything is working good, we take this thing into our UI. That means the same code where we are creating UI. So prediction function is built for making the predictions. When through the UI you are clicking the button, it is going to trigger the prediction function, and the prediction function predicted the value, and that value we are basically showing over as an output. Okay, so this is it. In some upcoming video, I'll also show you how can you take it from local host to the web server like AWS or something like that. Till then, just work on it and let me know if you find anything which should be asked, right? I'll just try to answer all your doubts. Thank you, everyone. We'll meet very soon in the next video.